Alright, so this video should be pretty short. It pertains to chapter 2 of your textbook, question number 8. So in this question, I'm asking you to calculate the pH of a whole bunch of different solutions. Right? With these problems here, one thing you should very quickly notice, or maybe the first question you should ask yourself, is are these strong acids or are they weak acids? Or are they strong bases or weak bases? Right? The reason why this is critical is that we treat both of them differently. So when we're trying to determine the pH of a weak acid, for instance, we're going to use the Ka equation or the Henderson-Hasselbalch equation. Right? Those equations are very useful for the weak acids or the weak bases. Right? When we're using dealing with strong acids or strong bases, however, we make the assumption that the strong acid or strong base completely dissociates when we put it into water. All right, so I'm going to give you one of them real quick. All right, so HCl, hydrochloric acid. All right, so when we put hydrochloric acid into water, all right, it's going to react with the water, right, and we're going to get, it will initially dissociate into H plus and Cl minus, and H plus in the presence of water is going to form hydronium ion. Right? So let's just say, we have 3 molar HCl, right? Each molecule of HCl is going to give us 1 molecule of hydronium ion and 1 molecule of chloride. So that means then that we're going to have 3 molar hydronium ion and 3 molar chloride in this case. Right? Hopefully, you guys know how to proceed from here. All right? If we know how much hydronium ion we have in solution, it's relatively easy to calculate pH, right? Because pH by definition is the negative log of the hydronium ion concentration. Right? So this works really well for strong acids. Right? If we're dealing with strong bases, right, in those cases, they're also going to completely dissociate. Right? But with a strong base, let's take another example that you see in this problem, NaOH. I'm just going to go ahead and tell you, all right, NaOH is a strong base. All right, so it is going to completely dissociate into sodium ions and hydroxide ions. So, all right, so whatever concentration of sodium hydroxide we had, we are going to have that concentration of hydroxide ions after it's dissolved. All right, now here we don't have hydronium ion concentration, right? So we can't directly determine the pH, right? But what we can determine is the POH. Right, so POH, anytime you have the small p, it just means negative log, right? In this case, the negative log of the hydroxide concentration. Okay. Put a little dividing line here. Sorry. All right, so if we know POH, right, we're dealing with water. Water, just like any other acid, has its own Ka value. In the case of water, the Ka value is 10 to the minus 14th, all right, which means that if we take the pKa of water, it's going to be 14, all right? And so this gives us a very useful equation here that then pH and the POH, when we add them together, they're always going to add together to give us the value of 14. So if we know POH, it's very trivial at this point to determine the pH.